So let's recap the velocity section here. So when velocity is negative, what that means is the car is moving left, moving west. If the velocity is 0, that means the car is just not moving. And if the velocity is positive, it's moving to the right, moving east. Okay? So right now we're going to bring in acceleration. And when some people hear the word acceleration, they think of, oh, well, the car is going to speed up. Well, it really depends on the direction. So I want you to think of acceleration as a force, as some sort of power. So that's over here. You notice here there's a character from a long time ago called Mighty Mouse. And Mighty Mouse is very, very strong. So let's see what happens. So if there is a force towards the left, that means acceleration is negative. So imagine Mighty Mouse pushing to the left. That means acceleration is negative. Now, if Mighty Mouse is somehow pushing towards the right, meaning applying a force towards the right, that means the acceleration is positive. And if Mighty Mouse is not doing anything, there is no force applied. So think of acceleration as force related. All right, so let's have a look at the first case. Now, the first case, as we can see, both velocity and acceleration is negative. So what does that mean in terms of the car and Mighty Mouse? So think of velocity as negative. So negative means that the car is going, it's actually moving towards the left. So as the car moves to the left, and now notice how I'm saying that the acceleration is negative. So imagine Mighty Mouse behind the car and actually applying a force to this car. What's going to happen to this car? The car is going to be moving a lot faster because of Mighty Mouse. So what that means is if a force is going in the same direction as the velocity, what that means is the car is going to get faster because Mighty Mouse is pushing the car in the same direction. So I'm going to put here, it is moving faster, or in that case, it's speeding up. So let's move on to this one over here. We're going to skip this one, move over to this bottom one. So now what happens if the velocity is positive? So that means the car is going to the right, but the acceleration is negative, meaning Mighty Mouse is going to be going against this car. So what's going to happen to this car if Mighty Mouse sort of like pushes the car? Well, imagine this, and then Mighty Mouse stops. So basically the car is going to slow down because there's a force going against that car. In other words, it is going to slow down. So over here, let's write this out, slow down. So slow down. So let's look at this corner over here where the velocity is negative, meaning the car is moving to the left, but acceleration is positive. What that means is you have a force going against this moving car. So what's going to happen to this car eventually? It's going to slow down because there's a force against it. In this case, let's write down slow down. Slow down. And over in this corner over here, they're both positive. So what that means is the direction is both going to the right. In other words, imagine a car going to the right, velocity is positive, but then you have an acceleration or you have some sort of force behind it pushing it. What's going to happen? The car is going to speed up. Speed up. So let's look at the middle column now. When acceleration is 0, meaning there is, so basically Mighty Mouse is not in the picture, not applying any force or not. So what does that mean? So the car is moving to the left. So over here, the car is moving to the left. However, there is no force behind it to make it go faster or slower. So basically what that means is there's no acceleration. That means the car is moving at a constant speed because nothing is making it faster or slower. In other words, it is at a constant speed. So it is constant speed, but heading to the left. And vice versa for the bottom one over here, the car, the velocity is positive, but there is no Mighty Mouse or no force to push it, meaning the car is going to move at a constant rate. The velocity is positive, meaning the car is still moving, but there is no acceleration. In other words, again, constant speed, but heading towards the right. And the middle one means, well, if acceleration is 0 and the velocity is 0, the car is not moving, it's at a standstill. So not moving. So not moving, nothing is happening to that car. For the two missing boxes, we're going to leave the boxes blank for now until we learn something in the next video. So over here for now, we'll just put a question mark here for now in terms of what that means. Or maybe you can find hypothesis of what you think that means in regards to Mighty Mouse and the car. Like when the car is not moving, but then there's a force on that car, what does that mean? So we'll save these two question marks for later on. So just recapping this overall chart without these two ones over here for now. Notice how when the velocity is negative, they're both negative, meaning they're both going in the same direction. The forces and the speed are going in the same direction. The car is going to speed up. If you notice here, when they're both the same sign, when they're going to the right, it also speeds up. So when the signs are the same for V and A, the car is going to speed up. However, we have the opposite effect when the signs are different. When A is negative and V is positive, meaning you have a force going against where you want to go, is going to slow down. Same thing for here, it slows down. And over here, when we look at when acceleration is 0, meaning, but you're still moving, that means the speed is constant, or you're just not moving at all. So here we have the very similar shape graph, but the only difference right now is our y-axis is talking about the speed or the velocity. All right, not speed with a sense of direction. So let's have a look at the velocity right now. Velocity here, notice, is all positive. I'm going to put here V is positive, V is positive, V is positive, because it's above the x-axis. So when V is positive, that means the car is going towards the right. At this moment here, where this dot here is, the velocity is on the x-axis, the velocity is 0, but afterwards the velocity is negative. Notice how this whole entire area here, the velocity is negative. So V is negative, V is negative, V is negative. What that means is the car is going to be heading in this direction. Now let's actually look at how the speed or the velocity is changing in each case, in each phase of this graph here. So let's look at this one over here, from here to here. Notice how the velocity starts off at 2, but now it's at 5. Well, that means what's happening to the speed or velocity has increased, meaning the car is going to speed up. In other words, the acceleration is also positive. Remember how I mentioned that when both signs are positive, the car is going to speed up? Over here, what's happening here? Notice the speed is always at 5 kilometers per hour, 5 kilometers per hour, 5 kilometers per hour. So that means the speed is always the same, meaning there is no push. The acceleration is 0. Now over here, what's happening here is, what's happening to your speed? It seems like the speed is going down. If the speed is going down, that means your car is slowing down. That means there has to be a force, an acceleration that's going against that direction of the car. Let's keep on going with this part over here. So eventually the car is going to slow down and actually not move at this certain point of time here. But what happens? Well, after that, the velocity is negative. What that means is, it seems like instead of going to the right, after this point here, it's going to the left. So meaning the car actually changes directions right now. So let's have a look here. What's happening to the velocity? The velocity starts off at 0 here, but it goes all the way down to negative, let's call it -3. So what that means is the car is increasing in speed, because you're going from 0 kilometers per hour to 3 kilometers per hour, but you're heading towards the left. So you are speeding up because you're gaining speed. In other words, the acceleration is going to be negative because you're moving to the left, and if the car is gaining speed, you're going to have some sort of force that's pushing you in the same direction so the car can move faster. Over here, this part here, it's flat, meaning the speed is the same, or the velocity is the same. That means acceleration is 0. And over here, the last part here, well, it seems like you're going from 3 kilometers per hour to 0 kilometers per hour in terms of the speed. What that means is you are slowing down in speed, or you are increasing your velocity, meaning the acceleration is going to be positive because it's going against the direction that you are initially going. So meaning you're heading to the left, all right? Your speed is due to the left, but then there's a force towards the right that's slowing this car down. In other words, acceleration is linked to velocity, and exactly acceleration is the change in speed, the change in your velocity. Sometimes I use the word speed interchangeably, but it should be velocity. In other words, acceleration is the change in velocity of the change in time, or we call it the instantaneous velocity over change in time. Another fancy word for instantaneous rate of change is going to be the derivative. In other words, derivative of v over t, or we can call it v prime t. So let's actually talk a bit about what's happening with this car over here from beginning of the story to the end of the story. So in the beginning, we just established that the car is going to speed up. So imagine you have a car, it's speeding up, and then eventually it just sort of coasts, all right? But then after that, we're talking about this area over here. What happens? The car in itself is going to slow down. So imagine you speed up and then you travel at a constant speed and then you slow down. So over here in this area here, what does that mean is the car slows down till the car is actually 0 kilometers per hour, meaning the car doesn't move. And what happens after this point here, over here? I'm talking about this area here. The car is going to, that's correct, turn around because the velocity is negative. So after this point here, the car is going to flip, go to the left, and the car is going to increase its speed, so it's going to go like really fast, and eventually it's going to coast at that flat part of the graph, and eventually afterwards, I don't have enough room, let's go back to here, so it's going to coast at that flat part of the graph, and eventually it is going to still head towards the left, but it's going to slow down till it just actually stops. So now I'm going to address those two empty boxes from the previous slide. When velocity is 0 and acceleration is negative. We had just established that acceleration is the rate of change or the slope of the velocity. So if you notice this area here in green, this entire area here, notice the slope is always negative. And that is why acceleration is negative. Acceleration is negative. Even over here, the acceleration is negative. So what that means is at this particular point here, where the v is 0, so I'm going to use this here, let's make a scribble here. So right over here, the velocity is 0 because it's on the x-axis, but at the same time, the acceleration is negative. So what is happening to the story? What this means is this point here, where the velocity is 0, it is called the turning point, because the turning point means when the car is heading towards the right, and after this turning, this black dot here, the car is going towards the left. So that means at this point here, the car is changing directions.